Hello students, in this video we will learn the other two type of function, that is onto function and into function. Let us see what is onto function. Onto function. Okay, onto function is also known as surjective mapping. Okay, like 1 was injective mapping, right? So onto will be surjective mapping. So let us see what is this onto function. Okay, let f is a function from a to b. Okay, suppose f is a function from a to b. Then let us see the condition. If each element in set B, that is codomain. Okay, codomain. Let me write it here together. In set B, okay, that is codomain. If each element in set B, that is codomain, is the F image, is the F image of at least one element in set A, means each element of set B must be some F image of at least one element in set A. Okay, every element in set B must be used, in other words. Okay, let us see. For example, let me explain you. For example, if f is a function, okay, if f is a function from a set of real number to a set of positive real number, such that f of x hold on, f of x is equal to e power x. Okay, f of x is e power x. Then see what is the condition for 1 function. Okay, RF, you see, in set B all positive real number is given, isn't it? And in set A all real number is given. So if your outputs comes out to be each element in set B, then we can say that it is a onto function. In other words, if your range means output, okay, if your range comes out to be equal to codomain, then you can say that this is a onto function. So what is the range here? F of x is e power x, right? F of x given function is this e power x. So what will be the range of e power x? We all know, right, that the range of e power x is range of function f is equal to 0 to infinity, isn't it? Look at the graph of e power x. It goes like this, right? This is your e power x graph. See, what is the range? The range is going from almost 0. 0 is not included, okay? This line will never touch each other, okay? So it is just above 0 and it goes on till infinity, okay? So the range is 0 open to infinity open. And your codomain is what? Your codomain given is codomain is also equal to, you can say that codomain belongs to 0 to infinity, both open, okay? So here we see that the range is equal to codomain, therefore we can say that the function is onto, okay? Let us see now what is into function, okay? Or before that, let me explain you through a mapping diagram how one onto function look. Suppose this is set A, this is another set B, A, B, every element here in set B, okay, must be the image of at least, isn't it, at least one of the element in set A. You may be left with some element in set A, but it doesn't matter, okay? It will be a onto function because all the element in set B is used, right? So let us see now what is into function, okay? Into function. Also we can say not surjective. Okay, this is not surjective. Let us see what this into function is. Let again f is a function from A to B, and it says if there exists at least one element in codomain which is not the image of any element in domain. Here domain is set A, okay, and codomain is set B, okay. So let us understand this through mapping. It says that if at least one element is left, okay, in set B, which is not the F image of any element in set A, then the function is into function, okay. Let us understand this through mapping. See, if this is set A, okay, this is set another set B. Here you write A and B, and F is a function from A to B. Here you can simply write element A, B, C. Here you write 1, 2, 3, 4. A has got F image 1, B has got F image 2, and C has got F image 3. Here the element in set B, 4 is left out, right? So since one element, or if more than one element is left in set B, then we can say that the function is into function, okay. So write it down. This is into function, okay. Let me give you another Venn diagram. Sorry, not Venn diagram, mapping. This is your another mapping, okay. See, one element goes here, and again one element is left out, okay. So if one element is left in set B, okay, or more than one, then we say that it is a into function. Into function. In other word, in simple word, you can say that a range is not equal to codomain. Codomain is what? Whatever the element is given in set B is codomain, right? And your output comes out to be not equal to the codomain. Then we say that this is a into function, okay. Let us understand. Let me give you an example, okay. A very easy example. I always give an easy example, right, whenever I explain the theory, so that you can understand. Later on we'll be doing some tough questions. Example: if f is a function from R to R, okay, and your function, what is function? Your function given is a x square plus bx plus c. So what do you think? Is this a into function or onto function? This is a into function, right? Because whenever you draw the graph of this quadratic, it is a second degree graph, isn't it? So the second degree, its graph, how will it look? Like a parabola, okay. Doesn't matter whether we have got the root or not, or whether the parabola is upward or downward facing, but after all, the graph of this function will be a parabola, isn't it? So when it is a parabola, then we can say that the range is not equal to real number, okay. Range will never come out to be real number. And here, what is your codomain? This is your domain, okay, and this is your codomain given in the question. So your codomain is all real number, but your range comes out to be, what is the range of the function? Range of the function does not belong to what you can say all real number, okay. It may be a part of real number, but it will not be all the real number, okay. So write a note, okay. Note, let me take this color. Note, okay. Even degree polynomial range is not equals to real number. Okay, the range is never equal to real number for even degree polynomial, but for odd degree polynomial range will be always, write it another point. Okay, I'll write in the same page. If it's an odd degree polynomial, odd, it's better to write in the next page. Odd degree polynomial range is always equal to real number. Okay, we have already seen this through diagram. Okay, the even degree polynomial, I have taken it as quadratic polynomial, and when we draw the graph of quadratic polynomial, the range will never come out to be real number. We have already seen. And when you take an odd degree polynomial, the range will come out to be real number. Okay, always it will be a real number. For example, when you draw the graph of x cube, f of x is equal to x cube, how will the graph look like? Can anyone say? See, the graph of x cube is coming from positive infinity, going crossing 0, the origin, and it will go negative infinity. Okay, so whenever you have got odd degree polynomial, the range will always come out to be what? Real number. So I am ending this video here itself. In the next video I will start a chapter called inverse trigonometry. Okay, so please be updated with my upcoming videos. Okay, I will start a new chapter, inverse trigonometry. Okay, thank you students.